My guest on the Weekly Squeak this week, and yes, I do appreciate that has become increasingly meaningless, and I will be renaming very, very soon. But for now, we'll stick to that irrelevant name. My guest today is William Morgan from Linkerd. Now, first and foremost, I had one apology and one question. We were going to be William and Jason Morgan. Firstly, Jason can't make it. Secondly, are you related? Or
Yeah, great question. No, we're not.
Oh, okay.
Just a funny coincidence.
Fair enough. And
Just
let's just start with a very, very quick overview of what Linkerd is and why someone might want to use it. Let's start there.
Sure. Yeah. So Linkerd is what's called a service mesh. Mm-hmm. It was the very first service mesh, the one that introduced that term into the lexicon. So if you are someone who's in the Kubernetes space, that term is probably, in your brain, and you probably want it to go away. So I apologize. But that's what that's what Linkerd is. And basically our goal is, if you're operating software, in the Kubernetes environment especially, but kind of generally speaking, cloud native software that we're designing to run in the cloud, then there's a set of features around reliability and around security and around observability that a service mesh like Linkerd can give you at the platform layer, rather than you having to build this stuff in the application. So the application doesn't know anything about this. Yep. We provide those features. We kind of sit on top of Kubernetes, and everyone is happy. At least that's the goal.
Let's go back a little bit, because generally I would ask what problem you were trying to solve. But I think when you mentioned it's one of the first, I guess it starts to answer itself. But I'd actually like to go back, because I've had service mesh. Well, Kubernetes generally is obviously increasingly big topic, and the observability and interoperability interviews I keep having. And some of those projects, like I had someone from Weaveworks on recently, and I remember WeaveNet from when that was the only way to the main only way to get Docker containers to talk to each other. And now we have lots of options. And so does Linkerd come from that kind of point in time when people were still tossing up between Kubernetes and Mesos and things like that? Or is it before that even?
No, that's exactly right. So, the first version of Linkerd was 2016, first open source version. And that first version supported Kubernetes, it supported Mesos, it supported Consul, it supported a Zookeeper. You could kind of connect it to different combinations of service discovery things. And a lot of the early adoption was people who were kind of migrating between systems. And then over time, that's evolved. And now our focus is entirely on Kubernetes. And of course, the underlying implementation for Linkerd actually has changed very dramatically from those early versions too. Yeah. But that's exactly that time period.
It's crazy, because 2016 does not really seem that long ago at all.
I was still, I was in elementary school at that point, so my first project.
I wish. But was Linkerd just the first thing to call itself a service mesh? Or were there other alternatives that kind of did the same thing at the same time, or similar concepts that you drew from?
No, not really. So, we actually went through this kind of difficult process where we had to come up with a name for it, because what we were building was something that was pretty unique, and our original names for Linkerd, we were calling it like an application proxy. Okay. We were calling it application router, and we were calling it like RPC proxy. And because our background actually came out of Twitter, and the original version of Linkerd was built on top of this set of Twitter open source technology that was, basically at Twitter was tasked with, how do I handle RPC calls between these services that are all in the JVM, and we're trying to do functional programming in Scala over RPC calls and blah, blah. So we had all this weird terminology in our heads that no one understood. And finally we were like, okay, well, let's call this thing, we need a new name. Let's give it a meaningless name, right? A name that is basically a big blank sheet of paper. We'll call it service mesh. No one knows what that means. Okay, well, now we can kind of, and then we can say, okay, and this is what a service mesh is. So it was a pure marketing term to call it a service mesh, but it actually was pretty different, because it's fundamentally at its heart, there are a lot of proxies.
Yeah.
And everyone was very used to proxies at that point, but they used these proxies in a very different way. And for them, a proxy was like this giant thing that you would stick in front of your entire, in front of your Rails application to make sure that Rails didn't fall over. And we were saying, no, we're doing something that's very different. We're taking this proxy, we're going to give you like 10,000 of them. And they're going to be really, really tiny. And people got very freaked out. So marketing solution.
Let's dig into that a little bit more then. So, I mean, for someone in 2016 or someone now, what is a service mesh?
Mm-hmm. Yeah. So I told you kind of like the value prop, which is around security and reliability and observability at the platform layer. The way that the service mesh accomplishes that is by taking these proxies, and ideally they're tiny little proxies, and sticking them next to your application, basically next to every single service, every instance of every service in your application. Mm-hmm. And that sounds great. Like circa 2016, that was totally crazy, because the idea of managing 10,000 proxies across this fleet of machines was like not something that anyone really had the appetite to do. But luckily, Kubernetes and containerization were starting to rear their beautiful heads. And that actually made that kind of deployment model practical. You could say, you know what, I'm going to take this proxy and like, you don't have to care what it's written in. It's just going to be a container. And I'm going to stick it in the pod, and we're going to do that kind of automatically for you. And so we don't have this deployment cost for doing that. So anyways, now you have all these proxies that are mediating the communication between your services, and those proxies can actually do things because they're sitting at both sides, right? So when A talks to B, there's a proxy on A side, there's a proxy on B side that can control that connection. And that means we can start implementing features like, we can do mutual TLS on both sides, or we can do retries, and timeouts. Or we can just, instrument like latency of all these calls and, are you getting successes or failures, and report those metrics. So that's the kind of implementation under the hood, is a whole lot of proxies. And then, there's like a control plane that sits over to the side.
So when you were creating Linkerd, what kind of did you draw on, seeing as this was something new? Where were you getting inspiration from for patterns and practices and the architecture?
Just pure genius, just innate genius shining through. No reference to anything else. No. I mean, we were building on top of stuff that to us had become very familiar again from Twitter, because we had just been, this was now, 2010 to 2014, 2015 was when we were at Twitter, and we is me, who likes to talk about Linkerd, and then my co-founder Oliver Gold, who actually does the work, and is typing as we speak. It's like improving Linkerd while I'm out, talking about it. But the two of us have been engineers at Twitter at a very transformative time, where Twitter was moving from this monolithic Ruby on Rails application into this big distributed, microservice application actually built on Mesos. We didn't have the word microservices, that was still a foreign concept. So we called it SOA. We knew that wasn't a good term, but we didn't know what else to call it. But anyways, Twitter had to build all this stuff to make that work. And one of the things it had to build was this library that handled the communication in between application components, right? And so that was so transformative at Twitter that when Oliver and I left, we were like, okay, this is something that the rest of the world needs to use, right? And then our only moment of tiny genius was, we said, hey, this, what this is it's like a Scala library, for doing functional programming over RPC calls. No one cares about that. No one wants that outside of Twitter. That's very niche. But if we wrap it up in a proxy, then, it's got these operational benefits. You can forget about the fact that it's functional programming and Scala and blah, blah, blah. We'll give you all these operational benefits around automatic retries and instrumentation. Yeah. And that's, that was, that kind of merged with the world of containers and container orchestration and all that stuff. And, the rest was just a whole lot of typing.
So let's go on the journey. I'm always interested to know when someone is at a company and you have something that is kind of an internal tool or an extension of an internal tool, what makes people decide to take it further. Mm-hmm. And first, I suppose we should start with, was the open source project something you were working on whilst you were still at Twitter, or did it become something you started almost immediately after you left? Or What was the motivation to kind of take into something new, I guess?
Yeah, so we started it after we left, but that first version was based on these Twitter open source projects. There's one in particular called Finagle that Oliver had worked on very heavily, and that I, at Twitter had been like a consumer of Finagle, and Oliver had been one of the implementers. So that stuff was, things we were developing for Twitter at Twitter. When we left, that was when we said, okay, let's turn this into like a more serious project. It's not going to be Finagle; it's going to be something else. We can build it on top of Finagle. Yeah. And again, over time, like we've moved off of that stack entirely, and there's all, totally different implementation. But that was the genesis of the idea. So, which is a little rare for open source companies. Usually, the open source project kind of gains momentum, and then you start a company around it. And you're like, okay, now I have to like bring it to the enterprise. For us, we did it in a different way. And
as far as I understand, the company open source project relationship is Linkerd and Buoyant.
Yeah, so Buoyant is the company that created Linkerd. Way back in 2017, I believe, we donated it to the CNCF. So the CNCF owns a trademark. Okay. It is like a CNCF project, and so Buoyant continues to be like the primary sponsor of the project. But it is a CNCF project. It's like accepts contributions from all over the world. Anyone can become a contributor and a maintainer. So it's like a full open source project. And that was part of our goal early on is, the one thing we didn't want to do. So we didn't want to do an open core kind of model. We didn't want to have Linkerd and Linkerd Enterprise where like we'd hold back features and like the enterprise version would, be the thing that you needed to actually do this in production. We wanted Linkerd to always be a first class open source project. So, making it a CNCF project, and even today we run it as like a fully open source, project that's decoupled from the stuff that we do at Buoyant. Okay.
So that was going to be my next question, because it's actually kind of nice that it's not very clear. You do work for Buoyant.
Well, I wear two hats, and like often I'm speaking with like the Linkerd hat, and and trying to decouple the Buoyant stuff. The Buoyant stuff is super cool, and it's very Linkerd related. I mean, we're basically building a managed Linkerd service, but like it's a different hat.
So then let's go back again. So Linkerd was the first service mesh, but there are many now, and I can see certainly on certain social media profiles quite a few comparisons between some of the main ones. And I do believe, I think I may actually be speaking to one of your competitors very soon as well. No. So we can ask from both sides. I don't necessarily want to dig too much into the us versus them stuff, but what I'm more interested in is knowing, like, when you are responsible for creating something new and then you get other people who take that idea and change it and do different things with it, how do you as the originators keep fresh and keep innovative and kind of beg, borrow, steal without starting to all become the same as each other, I guess?
Yeah. No, that's a really good question. Actually, I have a blog post I've been kind of brewing in the back of my head about this. So first of all, Linkerd is the best, and like all the other ones are crappy. So we'll just get that out of the. No, they're not crappy. It's just like, so actually I'll answer that question by answering your real question, which is, so everything was going great for Linkerd. We like launched this thing. It's called the Service Mesh. This is 2017 CNCF project, like fifth project accepted. Like it was like Kubernetes, Prometheus, something Linkerd. I was like, oh, this is great. And then Google came out with this project, and they were like, yes, we're announcing this thing, and it's a service mesh, and we're doing it with IBM, and I was like, oh God, like what's going to go on here? It's been an interesting dynamic, because suddenly we were in this very competitive situation, not just with like, another startup doing the same idea, but with Google and IBM, infinite amounts of money, to kind of throw, especially at marketing, which is kind of what they did.
That doesn't always mean very much. Sometimes a small company can have more cool. And although that's an interesting discussion, because of course cool only goes so far if you have to also have a business, but that's getting off topic a little. So.
So, for us, we had these early kind of really intense conversations. We were like, okay, what do we want to do? How could we, as a relatively small company, compete with Google, especially? So IBM is like, okay, who cares? That's it's a different category. But Google had just created Kubernetes.
Yeah,
Google
exactly.
was kind of cool in the same space, and we're like, okay, this is a serious thing. If we're going to do this, like, number one, maybe we could just join them. Like, maybe we just hop on the Istio bandwagon. We're an Istio startup. But, it just didn't feel like anything about that project was really expressing what we thought was important. And I think that was kind of the conclusion we came to. It's like, yes, they're calling it a service mesh. Yes, it's looking similar, and they have some good ideas, and, we'll happily borrow them just as they've been borrowing our ideas. But the goals around that project are different from our goals. The way they're going about it is different from us. And so it actually was really helpful because it helped us think about, what do we think is really important? What is the thing for us that we have to do with Linkerd that defines Linkerd? Is it some particular set of features? Is it blah, blah, blah? And what it came down to for us was, what we care the most about is simplicity. We think that the power of the service mesh can be delivered to you in a way that is simple. It doesn't have to be complex. It doesn't have to be this scary, massive amount of machinery. And by simplicity, I especially mean operational simplicity. So we had come into this as, as people who had been operating production software at very high scale, waking up at 3 a.m. when things broke. I remember I spent an entire Christmas day one day locked in the SRE room at Twitter because this thing I wrote had broken. And
Twitter breaking on Christmas Day is probably a bad thing. So
so we had a lot of empathy for our adopters, because and so anyways, that basically drove us onward. We were like, okay, we don't think what they're doing is right. We have to do this. This is a technology that has to exist. And I think early at that point, 2017, it was kind of a question. Now I feel like everyone has kind of recognized, yes, at some point I'm going to need a service mesh, and now there's the holdouts, are in the minority, whereas back then, the people who didn't understand or know about the service mesh were in the vast majority. So anyways, that's to answer your question. We had to do a lot of internal reckoning, try and decide what we really considered important. And then it helped us really focus on what that value was. And today, years later, Linkerd adoption is incredible. And we have people coming to Linkerd from Istio, all the time because of simplicity. They're saying, well, I tried it. I started there because I heard about the marketing. Now I come here and everything is simple. And that's really validating to me, because that was kind of our core belief way back then.
And 5 or 6 years later, how do you manage to balance that simplicity with, I'm not 100% sure how many features need to keep being added to a service mesh, but how do you balance that and keep that simplicity going and keep up with other alternatives?
Yeah, no, that's a great question. Every time you add a feature, it does introduce more complexity. There's more machinery. That's unavoidable, right? And so it's really a question about, when we do that, and we do add features regularly, of course, and there's more features we're adding, but when we do that, we are very disciplined in thinking through, what is the operational impact of this? What is the burden we're going to be imposing on the user, right? One of the very first features we added, which I'm really, really proud about, is mutual TLS, right? Mm-hmm. So we do TLS, between services, and we'll, we validate the identity on both sides. And it's a big part of this, zero trust security model, all this cool, and it's a big reason why a lot of people adopt a service mesh. And the way we did it, though, was we said, if we make this hard to configure, if we make this complex, if we make this something where you have to do a bunch of work, or you have to choose the right algorithm and add the key length and blah, 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 people are not going to use this, or if they do use it, they're going to set it up the wrong way and they're going to leave themselves vulnerable. So how do we make it so that when you install Linkerd, out of the box, we do this for you without you having to do any configuration? And that's, and we got there. It took a whole lot of effort, but that was a big part of the, kind of the discipline we're trying to follow, which is, yes, these features can be powerful and they can be complex under the hood, but you can't paper over it, right? Like the complexity is there. You have to present it, but you can present it to the user in a way where you reduce the friction, where you allow them to build a mental model of what's happening in the software. Basically, you allow them to operate the software without it being this like scary black box that's just going to break randomly one day, and I'm going to have to go, dig through the code.
That's actually a concept I've always been a big believer in. It was something that was mentioned when I studied computer science, and it was called HCI, human-computer interaction. It's a term I've resurrected many, many times, this abstraction concept, making something very complicated seem very simple. And something like a service mesh on container orchestration is probably particularly hard because the problem area is inherently complex. But there's already enough going on. So I
actually don't think it is. If you look at it, I think the world of consumer software has gotten very good at HCI, right? You look at the iPhone, like what's going on in there? Holy crap, it's incredibly complex. Yeah. But, it's so simple that you see like 6-month-old babies, like, swiping through there, right? I don't think the service mesh is more complex than like the full stack of software that goes into an iPhone.
True,
I don't think so. I think the infrastructure world is just lacking that empathy for the end user, because we are all, we're all engineers who like to build infrastructure. We like to add more things. We like to build the ultimate platform. That's our bias as engineers, right? And it takes a real sense of empathy. It takes a real amount of discipline to like not do that and to think about what is this going to look like to our users. That's a big change, and I don't think we've gotten there as an industry.
So actually, I feel like this question may be a reiteration of the last question, or maybe just kind of digging a bit more in. But that that kind of, it's strange because the saying you have something that's opinionated was almost a pattern from a few years ago. Things like Ruby and Rails and things like that was very opinionated, and things sort of became more and more configurable and less opinionated in some ways. Yeah. So, I mean, especially when you're in this kind of space where there are so many knobs that people can tweak, and they're given something that's like, well, actually, no, we're not going to give you that many to tweak. Again, how do you balance kind of that with your driving as a project goals? This pull request is great, but doesn't suit us. We want it to be simple, that kind of thing.
Yep. I think it comes down to design and having a really clear idea around the design, right? It's not, it's not really one or the other. It's not like you can either have features or you can be simple. You can have both if you do those features the right way, and if you're very thoughtful to like what the impact is and what the like resulting complexity, especially operational complexity for our adopters, is going to be. So if you look at, one telltale sign, and I'll pick on Istio a little bit, but, if you look at the number of CRDs, right, these are like Kubernetes custom resource definitions, right? This is like kind of like additional database tables that you're adding to Kubernetes. Istio at some point had like 53 of these things, and, Linkerd had 2, right? Like, why is it because CRDs are not powerful? No, it's because like we love CRDs. Actually, they're annoying to maintain, right? And so we try and design our features so they don't have that, right? And like, so you can do this. You can accomplish it. iPhone does like a million things, right? Like that are all amazing. I'm like, using TikTok and it's like talking to a wireless network and just playing a real life video and blah, 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 So these features can be delivered in a way that is not complex. It's not either or.
Yeah. Okay. And so let's have a look.
Linkerd is the iPhone of the service mesh world. I don't know if I really like that. But I'll throw that to the marketing team.
So about what month are we? Oh yeah, 6 weeks ago or so, released version 2.10, 2.10, however you refer to it. Yep. So actually, one interesting thing you mentioned here as a new feature is extensions, which is kind of an interesting feature, bearing in mind some of what we've just spoken about. It's kind of almost offsetting some of the simplicity elsewhere to let people maybe kind of do what they want without changing the core project too much. Is that kind of the idea, or? Well,
I think that's a great example of like, how do we add additional functionality to the project without making the project itself like more complex overall? So composability is one of the fundamental tools for doing this. So we can say, hey, now the control plane, the kind of core components for Linkerd are actually smaller than they ever were. There's fewer of them, right? There's like less you have to worry about. if you want like a telemetry stack, then like you can add this component and it takes care of all that stuff for you. But if you have an existing telemetry stack, then like you don't need this thing. So like, why is it even in there? Right. And likewise with, the other things that we pulled out from the core and turned into extensions, multi-cluster machinery, like not everyone needs it. If you do, then like, great, you can add it as an extension. Okay, yeah. And then of course, the thing that I'm really excited about is that we made this something that of course, project's fully open source, but we made the extensions kind of doubly something that anyone can add, right? It's like an interface. It's not hard to add an extension. We want people to do this. Like we want you to have the tools to do this. And really what the extension model gives you then is like a way of making that cohesive with the rest of the community. So I'm actually really happy with the design.
And I'm guessing it's an open extensions framework. So beyond, have you had many contributions of those yet? Or is it sort of too early days?
We've had a few. I think it's still early days. We didn't prior to 2.10, we didn't make the rounds and try and garner up, like, hey, does anyone want to co-launch an extension with us? So we've had a few, the stuff I'm really interested, and I think Oliver's interested into getting into extension land is things like SMI, where we have these like parts of Linkerd that are specific to implementing the SMI interface, which is like useful for people who care about SMI. And if you don't care about it or you're not using any tools that drive SMI, then like it's kind of superfluous. So we can move that stuff into an extension. Or the other one that I'm excited about is like ingress, right? Yeah. Linkerd has never shipped with its own ingress controller. We said, hey, we work with every ingress controller and like they do a great job. So like, why would we do that? But we can make it easier for you to kind of install one of those ingress controllers and have it work with Linkerd in a way that's seamless and so on by using extensions. So I think we'll see a lot more of them in the future.
Okay. And what's on the roadmap for 2.11, 2.2,
we're done.
Whatever maybe?
We're just resting on our laurels now. We've basically achieved the perfect service mesh, and so
fair enough. Okay.
We're just
concentrating on making cool T-shirts then.
Right. So we've made so 2.11 is going to be focused around policy, which actually is been towards for a long time. And I talked about MTLS, right? Like all of the MTLS work that's happened over the past couple of releases has all been in service of kind of the core thing that we need, which is we need identity. We need to know when A talks to B that you are A and I'm B, and like we can validate that on both sides. And on top of that building block, we can now start building policy, which is specifically saying no, right? So like right now, you make a connection through Linkerd, it says yes all the time. Like A wants to talk to B, Linkerd will do its darnest to make that connection happen. With policy, you'll be able to say, actually, you don't want that to happen. A is not allowed to talk to B under these conditions. So that's the big feature for 2.11.
Okay. And let's just very, very briefly cover Buoyant as well. So what does Buoyant, Linkerd Enterprise, I don't know, whatever you want to call it.
No, we're not doing Linkerd.
No, I know. But what does Buoyant add on top?
Yeah, so we have a product called Buoyant Cloud. It is in early access. We've done no marketing about it.
Feels like I know the name, though. It feels like I've seen it.
Okay, great.
But
That's a great name.
Maybe I'm thinking, you know what? And this is I don't want to offend you. Maybe it just makes me think of Joyant. Maybe that's the problem.
Oh, yeah. Okay. Well, it's not.
We don't exist anymore, I don't think. So that's okay.
It's called Buoyant Cloud. And it's basically a managed Linkerd service. So, if we make Linkerd as simple as possible, of course, but like operating any software still is a burden, right? You still have to set up alerting. You still have to worry about it. You still have to wake up at 3 a.m. So we want to take that operational burden off of your shoulders as much as possible, make it even simpler. There's still components that are going to have to run on your cluster, of course. Like you can't have the proxies sit over here and like we can't host it for you. Like every call goes across the internet and back, and there are components that are running on your cluster, but we can manage those for you and we can make your life a lot easier. Okay. So if you're a Linkerd user today, you can check it out. You can get yourself into the early access program. It's super cool. We've got all sorts of other neat features like SLOs and rollout tracking and stuff in there. But fundamentally, so it's all about reducing the operational burden, making the service mesh even easier for you to operate.
And so timing-wise, we're speaking the week before KubeCon EU, in quote marks at the moment. What's your main aim, goal there next week?
Oh gosh, we've got like so many Linkerd talks there. This is like a particularly good KubeCon for us. I actually am delivering a keynote, which is kind of cool. I'm talking about how Linkerd has been used by the Linkerd community to combat the COVID-19 global pandemic. So I'm going to like highlight a couple use cases. Super cool. Some of them are actually full-fledged talks. And then we've got folks, Linkerd adopters talking about all the different ways they've used Linkerd. And Oliver is at the Cloud Native Rust Day, one of the Day Zero conferences, talking about why Rust is the future of the cloud. Of course, Linkerd, the proxies built in Rust, all sorts of cool stuff and security benefits we get from that I didn't even, we didn't even get to cover this time. Maybe we'll do that next time.
I think it must have been one of the earlier big projects outside of Mozilla that was using Rust then, I guess.
Yeah, that's right. I mean, we actually kicked the tires back in 2015 and we were like, oh, this is a little bit too early. But then starting around 2000, I kind of mentioned we migrated off of the Twitter stack, which is all JVM based. Yeah. And the modern Linkerd control plane is written in Go and the proxies are written in Rust. We get all these cool benefits, security benefits, and so on. And like the other amazing thing has been that ecosystem is on fire right now.
Yeah.
All the most modern, like asynchronous network programming tech that's happening in the whole world, it's all in this Rust ecosystem. So I think the Linkerd proxy is like probably the most technologically advanced part of the entire Kubernetes or CNCF landscape at this point, because it's just cool stuff that's happening there. But
and nicely growing much beyond the originators. In fact, the originators are probably the people you hear from least, which is kind of interesting for various reasons. So that was a bit of a gamble for us, a couple of years ago, the choice of Rust, but it's paid off so nicely. I'm so happy with how it paid off. So Linkerd is Linkerd.io. I mean, just in case anyone's confused by that, Linkerd.io. And for you personally, I'm guessing your ex-Twitter employee status equals why you have the quite cool Twitter handle.
WM. Yeah, it's actually kind of annoying because people like to tweet like William and Mary College or about WrestleMania. And so
I was just thinking William Morris, which shows you I'm obviously very outdated. Obviously, William Morris would not have a Twitter account, but anyway, because long since dead. But anyway, I digress. Anything else you quickly want to mention that we haven't mentioned for KubeCon, for future announcements?
Yeah, no, I think we've covered all the basics. Linkerd adoption continues to skyrocket. Please give it a try if you're in the Kubernetes world. I'd love to get your feedback. Linkerd has been proposed for CNCF graduation, so hopefully we'll have some good news on that front. I don't know if it'll happen, but probably not by KubeCon.
I hope you know by now. Yeah.
Right. And then if you are a Linkerd user, I'd love for you to check out Buoyant Cloud because I think we can do a lot of cool stuff for you. So
cool.
I think we hit the highlights.
Yeah. William Morgan, thanks very much for your time.
Thanks for having me. This was great.